In the last video about XCM, hope like you already get the basic understanding of what is the XCM, why you need XCM, some key attributes of XCM, and also like the overall architecture of the XCMs, like the XCVMs, XCM executor, instruction register. Today we're gonna learn about some fundamental concept in the XCM, like the location and the asset, and also some of the way that you can transfer the asset in XCMs. Okay, so now we go back to our visualization and also the documentation, XCM official documentations. So the topic that we're gonna learn today is the multi-location. So what is the multi-location? Just imagine that the multi-location is like the URL or the identifier of the address of the consensus system you're gonna send to, and also here the consensus system not only the multi-location, not only the consensus system like a blockchain, but also represent the ERC20 asset account, any sub entities inside the consensus system. It must be relative to the current locations, like a parachain. And the location is relative, so multi-location always express a location relative to the current location. It can be thought of as a file system path, so without the ability to directly express the root of the file system tree. So this is for a simple reason. So in the world of Polkadot, so blockchain can be merged into and split from other blockchains. So a blockchain can begin as a standalone sovereign chain, doesn't connect to any kind of other big network like Polkadot, and could eventually be elevated to become a parachain with a larger consensus. So if it did that, then the meaning of root would change overnight, and this could spell chaos for XCM and anything else using multi-location. So to keep things simple, we exclude this possibility altogether. Location in XCMs are hierarchical, so some places in consensus are wholly encapsulated within other places in consensus. So a parachain of Polkadot exists wholly within the overall Polkadot consensus. We call this an interior locations. So right here, so interior location, a parachain of Polkadot exists wholly within the overall Polkadot consensus. Given the two consensus system A and B, A is interior to B if state changes in A imply a state changes in B. That's mean if the parachain make a state changes, the relay chain also follow that state changes as well. That reason why the parachain is also an interior location of the relay chain of the whole Polkadot network. So what is a multi-location? Simple example right here. So a quick summary of the reverse point. Multi-location identify any single location that exists within the world of consensus. A multi-location is always relative to the current locations. If it's Polkadot, then the parent gonna Polkadot. If it's Kusama, then the parent gonna Kusama, and then the parachain path gonna follow that root path. So multi-location is hierarchical. So now take a look at the multi-location structure. So here is the structure of the multi-locations. So you have the parent that point to the relative location ID of the parent, and also you have the interior, which is the junction. We're gonna learn about the junction later. So as we already learned, location in XCM are hierarchical. So as you can see, the relay chain, parachain is the tree, it's like a tree, and then the parachain is one node of the relay chain. Parachain B also on the same level of the parachain, and then you have the account, which is inside, which is the interior locations of the parachain A. So let's say there's also an example to represent the locations that follow the relative path. So let's say if you form the relation A right here, that you want to specify the path, the multi-locations go to the location of the parachain 2000, then you're gonna point from the relation to the parachain B with the locations parachain 2000. Then what you're gonna do is you specify the parent as 0, which means your current location is the relay change, and then the interior gonna be x1 parachain 2000. The x1 right here is called the junction, and we're gonna learn the junction later. So x1 means one junctions. You go to 1 and then parachain. So there's a depth level of the junction, but we're gonna learn later after this multi-locations. So let's say if you form the relation A, you want to go to the account in the parachain A, then your junction right here must be you still in the parent 0, which is like the current relay change, and then the interior gonna be like the x2 junction gonna be like the two it's like slash like the parent 1000, like you point to the parent 1000, and then you slash again like account ID 32 network with the address of the account ID. Then similar, so let's say if you form the parent B and you want to go upward to the relay change, go to the directory, you're gonna specify the parent as 1, and the interior is here. That means like you want to go to the parent, not like the current one. So the interior is gonna be here. So if you want to go to the account in the parent A, so it must be, as you can see, it's like a file system, right? Like dot slash the parent 1000, go back. Go to the parent 1000. So you're gonna specify the parent as 1. That means like you go back and then you go to the junctions. So because you are currently in the parent B, so you want to go back to the relation A first. If you want to go to the parent A, so you go back to the parent and then you go to the parent 1000, which is the parent A, and you specify the account. So that's how the example is gonna work. Now, there's another type of location that I also want to mention here, which is a universal location. So let's say if you have a Polkadot, a Kusama, Ethereum, or any kind of consensus system that is like a global one, but you might want like a very global one that actually like doesn't use anywhere, but it's also like parent of all the locations. And that is called a universal location. The location used for all the other locations to generate their own consensus, doesn't have any parent. This is like a very like root of the root. Yeah, the universal location is a theoretical location. It's the parent of all location which generate their own consensus. It itself has no parent. Yeah, like the locations, the parent of Polkadot or Kusama. So now we go to the junctions. So what is the junctions? So in the section multi-location, we look at the multi-location struct. We talk about the multi-location being a way to describe moving from one place in the system hierarchy to another. The parent parameter expresses the number of steps up in the hierarchy. In this section, we dive further into the multi-location struct and explain how we can use the junction type to describe step in the system hierarchy. Take a look at the multi-location struct again. So we have the parent and the interior. System hierarchy consists of 1 to n relations. So each place in the system hierarchy can only ever have one parent. So there is only one way up to the hierarchy. That is why we use the U8. So the parent specifies like how many the level of the parent that you want to go up, because you actually only have like a tree right here. You only have one single parent at the end, which is like the universal location, or like the location of the consensus system. But moving down is a bit more difficult, as one consensus system can encapsulate multiple other consensus systems. Like a relay chain can have multiple parent change. So to describe the correct step down the hierarchy, we use the junction type. And the junction type right here is gonna have different type. Like first, this junction gonna be here, like the interpreting the current consensus system, or the relative path comprising one junction. So x1, like you want to go to this path, and then like if x2 you're gonna go to this path and then slash another path, then it's up to like the 8th junction, because actually like this can never be any case that like you're gonna have like 8 different path in the tree of the consensus system. It's gonna be quite crazy. So right here, there's a junction. Some of the junction type can be added into the junctions. So the junction type include the parent change. We're already familiar with that. It specifies the parent change in the global consensus system like Polkadot. Then the account ID 32. This type of account is used in substrate. Account key 20. This type of account is used in Ethereum, like Ethereum similar system. Account index 64. Another type, and also a network ID palette instance. Like let's say like if you want to specify like the parent change, and then you want to call to the palette instance like an NFT or something, and then generate index of the NFT. Like let's say if I want to specify the collection ID of the in the palette NFT, like like 0 or 1, and then you have the general key, specify the general key of the palette core or something. I'm not sure like why is this only try, but yeah, blue row DD and global consensus. We can also actually look at the real code instead of just see this example. Yeah, so in this junction we're gonna have the parachain, an index parachain belonging to and operated by the context, a 32-byte identifier for an account of a specific network that is respected as a sovereign endpoint within the context. So as you can see, like account ID 32 generally used when the context is a substrate-based blockchain. And an 8-byte index for an account of a specific network that is respected as sovereign endpoint within the context may be used in the context is a frame-based change and include an indices palette. It could be there, not substrate, but it's just frame. It's possible as well. A 20-byte identifier for an account of a specific network that is respected as a sovereign endpoint within the context may be used when the context is Ethereum or Bitcoin change or smart contract. These are account key 2020. Palette instant generally used when the context is a frame-based change, and is an instant an index of the palette. General index, so a nondescript index within the context location. Yeah, datum acting as key within the context location. So these are not like recommended to use, but sometimes we also have to use that if we want to specify any kind of asset that need dynamic structure. So like the unambiguous try, a pluralistic body existing within the consensus. So those are like some of the type of the junctions that can be added into the junctions, X1 or X8. Yeah, those are the junction type. Here, there are also another type called global consensus, or it's a global network. Polkadot or Kusama is capable of externalizing its own consensus. This is not generally meaningful outside the universal level. It's implying the universal location here. So an example would be describing the Kusama relay change from this perspective of the Polkadot relay change. So as like parent 1, that's mean like from Polkadot, you want to go to the parent with a universal locations. Then you go to the global consensus Kusama. Yeah, so we're gonna specify the parent ID interior global consensus. So it's like if you want to send the token from Polkadot to Kusama, it's definitely can also be possible to do that. An example use case could be like routing XCM between global consensus network using bridges. So there's a multiple way to create locations. Here that you can see that you can create a location like multi-locations parent, or use new, or use here default. Yeah, and all like if you want to specify the parent location, you can also like use the parent 1 interior here, or multi-location parent. Conversion, it can be also like from this multi-location. You can also like just specify the path, like go to the parent and then the parent again. Specify go to the parachain 1, general index 1, then the into, and then it's gonna like construct and then like build up the struct multi-location. Now we're gonna take a look at some of the example of the location. So as you can see here, to give it the context, so we have like the two relay change, which is two global consensus system, relay A and relay B. Then like in the relay A, there are two location like parachain A and parachain B. Parachain A is a normal Polkadot blockchain, super blockchain, I suppose. So it's gonna be using account ID 32, yeah. And then like parachain B gonna be the EVM, so it's gonna use like account ID 20. Then it also have a smart contract with the 20-byte key. Then in the parachain A, which is a substrate blockchain, it's gonna have the palette with also like the asset ID 1. The palette index is 1 as well. So in the parachain B, you have like the plurality. I guess like it is like some kind of governance account or something. Then like account ID 32. Then a substrate. Yeah. Then we have like the parachain C, with the ID 1000 and the NFT class 1. So you can select Persian A and Persian C actually have the same ID. So from the perspective of the relation A, then you can specify some path. So if you formulate the relation A and you want to go to the Persian A, then what you can do is like you can specify that Persian 1000 and into, because like from the relation you just go downward from this level, that you don't have to go anywhere else. You don't have to go up, so you just specify Persian and 1000 into. It's quite easy for the global consensus case. Then if you want to go to like account ID 32 in Persian A, you specify first the Persian, and then just go downward again, account ID 32, and you can see the network relay A network, and then the ID into. Then how about the asset in the Persian A? So to specify the asset in the Persian A, you have to use the palette index with the ID 1 and then the general index ID 1. So you can see right here, it's gonna set the palette instant 1 and then general index 1 to specify the asset in the palette EZ. How about the Ethereum based account Persian B? So let's say if you want from the relation A, you want to visit this account ID 20. You from the relation A, specify the Persian B, and then go to the account ID 20. So as you can see, it's going to be the Persian 2000, which is the Persian B, and then the account key 20, similar to the one that we have right here. And how about the smart contract? Also like similar to that, we're going to specify the palette for the smart contract, which is as the palette instant 1 with the smart contract 20 by key. We can use here is still the account key 20, because a smart contract is actually still an account in the Ethereum network. How about the relation B? So if you add the relation A, you want to go to the relation B, we're gonna go like one path up to the parent, and then this is our universal locations, and then we go downward to this global consensus relation B, parent relation B. Okay, how about the NFT on the Persian C? So because like we already at the relation B, we just specify the palette instant. We specify the Persian C with the ID 1000, then the NFT class a general index 1. Yep. Yeah, I think it's very clear. And from the perspective of the Persian C, if you want to go to the relation A at the Persian C, if you want to go to the relation A, specify the parent, go up to the relation B, parent again, go to the universal location, and then go to specify the relation A as a global consensus. Plurality example. So many more body ID part compose imagination. So you can also go to the parent, and then from the perspective of the Persian C, you will go to the parent and then specify the plurality. Yeah. Account in the relay. So if you want to go to the account to the relay, just still go to the parent and then let's specify this account. Yeah. I think this must be wrong here. Like in this example, this should be the relay B, not the relay A. Should be relay B. If it's relay A, it must specify the global consensus, similar to like what we had before. From the perspective of the smart contract, so if we are the smart contract, we want to go to the asset in the relay A, then we're gonna go to like parent, and then a parent, then parent again, like the three parent, and then we go to Persian A, then the palette, and then instant parent, Persian, palette, instant. Yeah. And that is the example of the multi-locations. And I think like this is a very interesting topic. In the next video, we're gonna like try to solve some of the SSI related to this location so that you can understand it fully. Now we're gonna move to the another fundamental concept, which is a multi-asset. Because we already have the location to specify as the identifier for the global consensus, the global consensus system, and also the interior location in that global consensus system, then account, smart contract, or any layer chain, right? Now we also want to about the multi-asset. So when working with XCM, it's often needed to represent an asset of some sort. So this is because practically All public blockchain in existence rely on some native digital asset to provide the backbone of its internal economy and security mechanism. So for example, like the native asset for the Polkadot relay chain is DOT, and some blockchain manage multiple assets like Ethereum ERC20 as framework allow for many different assets to be managed on chain. So some managed assets that are not fungible, so Ethereum CryptoKitty or like ERC721 NFT. Each kitty is one of the kind instance. It were an early example of such non-fungible token or NFT. Later on, like when there are more innovation to the blockchain space, they're gonna be like more carved asset because like that is the that's still like blockchain is created for like digital economy. And XCM is designed to be able to describe all such asset without breaking a suite. So for this purpose, there is the multi-asset data type, along with its related type, multi-asset, y-asset, and multi-asset filter. And so I have is over here, so you can have the full view of the asset. So for the asset, we're gonna have like the multi-asset, where we just talk about, and then y-asset and multi-asset filter. We're gonna learn one by one later. The data type of the multi-asset gonna be like the ID as the asset ID, and the fund, which is like the fungibility, like fungible or non-fungible. And fungibility, we have the fungible. Like when you specify the fungibility as fungible, that means it be like countable more than 0, so it must be a non-zero amount. Like ERC20 or like in token in the Polkadot asset. And fungibility, if it's non-fungible, that means it's an NFT. So like the asset, it must only have one single instance. So you doesn't have like to specify the amount here. For the asset, we're gonna have the asset ID. So it must be the concrete or abstract. So as the concrete, you can specify using the multi-location, similar to what we have in other example. Let's specify the concrete locations from like the consensus system to the palette and then also to the asset, or you can using the abstract or the binary blob of the asset. And how to use like the multiple asset together. So to use like multiple asset together, you can use a struct type called a multi-asset. This multi-asset is actually a new type in Rust, and then it contains the vector will like contain like multiple asset. And this structure must oppose some rule. It means not contain a duplicate asset. Fungible asset I consider the same if they are the match. So however, like non-fungible asset are different if the asset instance is different. So all items must be in order. The number of items should row no larger than the max item in the multi-asset, currently set to 20. So like the multi-asset can only like contain up to like 20 items. Y-asset, so that then like we have like the Y-asset. This is a wildcard type of the asset, can be used to match again one or more multi-asset items. So when you let's say like if you want to send multiple asset from like one blockchain, you can actually use like Y multiple asset, specify like the or the or of that. You can like specify the ID and also like the fungible of it. Or asset in holding, so up to like U32 individual asset, different instances of non-fungible as separate assets, so all counted or of counted, or asset in holding of given fungible. Multi-asset filter. This is used most often and is just a combination of multi-asset and Y multiple asset, allowing either a wildcard or a list of definite not wildcard asset to be specified like multi-asset filter. You have to type like definite or white. If it is white, then like you can specify the filter as a given Y multi-asset wildcard, or like you can use like definite that specify the filter as being everything contained by the given multi-asset inner. About here like some example of the asset. So you have the location and relay change. If you want to specify like 100 native asset, there's 3 ways that you can do that. The first one going to be like using concrete and the multi-locations. So when you use like multi-location, you don't have to go to any parent. You right here the current relay change, and then the fungible is the fungible 100. Then you can also use it here into and then functionality as well. The multi-asset, so 100% native asset, then you can use the junction to specify the multi-locations. This is actually like the concrete multi-location. So you specify the junctions and the parachain 1000 with the native asset 100. Yeah. And then if you want to send the fungible asset from the palette ID 1234, if you want to send a fungible asset from the parachain 1000 with the ID 1234, you can specify the junction x2 parachain 1000, and then specify the index, the ID of the palette of the asset, the fungible 1234, and the amount. Then non-fungible as well. Then you just specify the junctions, the parachain ID with the general index of the NFT, and then here you keep it undefined because it's an NFT instant. Using into is gonna translate directly to you. Then you can also use non-fungible asset with asset class 1234, and asset instant is 1, and then you can do here the index 1 as the asset instant. Yeah, because right here this non-fungible asset is only have one NFT instant, so you don't have to specify any instant of the palette NFT because you keep it undefined. It's gonna point to the one is confined. Then if you specify the instant right here, it's gonna go directly to asset instant 1. How about the multi-asset filter? For the multi-asset filter, then you have the multi-asset with the vector of the multi-asset, and you can also do the definite or the white using the white card, or definitely specify the asset directly. And there's also all the sections about multi-locations and the multi-asset, and I hope those fundamental knowledge gonna be helpful to use and help you to understand about the subsequent sections of the XCM. In the next topic, we're gonna learn about how to transfer in XCM, and also how to write your XCM instructions, some different ways of the XCMs like teleport, reserve, back transfer, and those are very interesting topic, and see you guys in the future video.